Hello, this is going to be me going through section 5.5. So what we're going to do is some factoring and using some synthetic division. So we've used synthetic division before to evaluate polynomials. So now what we're going to do is actually divide polynomials. So it's like unfactoring in a way, or like undistributing something using synthetic division. And we're going to end up using that then to factor them further. And then eventually we'll end up solving. So a pretty short video. I'm only going through 6 problems. And we'll just start off with just dividing polynomials using synthetic division. So again, it's another way of like undistributing something. So what we're going to do first is say that we're taking this entire polynomial divided by this little guy. So the first thing that we do is we take the opposite of this. So I'm going to, instead of the -2, I'm going to put a little +2 here and put a little box around her. And then I'm going to take the coefficients for each one of these variables and just line them up here. So what you want to make sure is that you're going highest to lowest and that you're not skipping over anything. So notice the powers are from 4 to 3 to 2 to 1, and then we have our constant. If, for example, there was no like 4x to the third here, and it went right from the 4th power to the 2nd power, you would want to put a little 0 in there as like a placeholder. So since this is 1x to the 4th, I'm going to put a 1 here. I put a -4. +2, a -3, and a +1. So far we've used synthetic division to evaluate polynomials. It applies the same way. We're going to bring the 1 down first. You're going to multiply the 2 by the 1 and get 2, and then add going straight down. So I get -2. Do the same process. Take this 2 times this -2 and get -4. Add going straight down again, I get another -2. Repeat the process again, 2 times -2, again it's -4. Add going straight down, I get -7. And then I have 2 times the -7, which is -14. And we add going down, and this is your remainder, is the -13. So you're taking something that is raised to the 4th power divided by something that's raised to the 1st. So if you were to take anything to the 4th divided by anything to the 1st, you're basically dropping a power off. This means that this 1 really means 1x to the 3rd. So it just decreases the power by 1, and then you would say minus 2x squared minus 2x, and then -7. So where the 13 comes in, that's a remainder. So we say minus 13 over what we had originally, which was x minus 2. So just to recap, because that is the end, just to kind of recap this, is we took the opposite of this value. Since it said x minus 2, I have a +2 here. You took your coefficients, so the numbers in front of each variable, and we just dropped them down here. The 1 came down, I multiply it, and then you add going straight down and keep repeating that. So the reason why we start with having a 3rd power here is if I took what I have in green and I multiplied it by x minus 2, and you went through one term at a time and you distributed, you would end up with this big one right here. Okay, so we are technically dividing these. These are just a shortcut. So I'm going to go through another example of this. So in this one I have a cubic function. This one looks a little bit smaller, but notice I'm also missing anything that's raised to the 2nd power here. So the first thing that we do is we take the opposite of this, and I'm going to put a little -3 here and box it up. I'm going to bring a 2 down here because that represents 2x to the 3rd. Now I have no x squared term, so I'm going to have to put a 0 here as a placeholder, and then it goes to my x term, or x to the 1st, which is the -8. And then I have a +10. So I'm going to bring my 2 down first. That's kind of just the general rule with synthetic division. So the 2 is going to come down here. I'm going to multiply. So that gives me -6. I'm going to bring this down again. 0 plus -6 is -6. -3 times -6 is +18. Add going straight down again. -8 plus 18 is +10. And then I have a -3 times a +10, which is -30. Add going straight down, my remainder is -20. So my new answer, or really the polynomial, is this part right here. So since this was starting with a 3rd power, and you're dividing by something to the 1st, that tells me this is going to be 2x to the 2nd then, minus 6x, and then +10. So where the -20 comes in is I put minus and then the 20 all over x plus 3. And again, the green part is your final answer. So that is the quotient. So it's basically your answer when you're dividing these two things together. So something to mention is if your remainder comes out as 0. What that means is you would be able just to take whatever you have here where I'm kind of highlighting and multiply it by what is here, and you would get that answer without having the remainder. So a remainder of 0 implies that something is actually a factor of our polynomial. So in these following ones, we're going to assume that something is a factor. So what you're going to see here is we are going to factor these expressions. But when we do it, what you're going to notice is our remainder is going to come out as 0 first. And then we're just going to factor from there. So let me show you. So starting with this one, we take the opposite of x plus 2. So I put a negative 2 here. Notice it goes from 3 to 2 to 1 and then a constant. So no placeholders. So 3, negative 1, negative 10, and negative 8. I'm going to bring this 1 down. Negative 2 times 1 is negative 2. Add negative 1 plus negative 2, which is negative 3. Negative 2 times negative 3 is positive 6. I now have a cat on my lap. Harley, please. Alright, negative 10 plus 6 is negative 4. Negative 2 times negative 4 is positive 8. Like I said, when you add these straight down, bam, you have a 0. That implies that the x plus 2 is a beautiful factor of this polynomial right here. So watch what happens. I can take this remaining part, and again, since we're taking something to the third divided by something to the first, I would drop a power. So 1x squared minus 3x minus 4. And the beauty of some of these problems is the expression that you are left with is going to be factorable. So in our case, I want to see if I can factor this. In other words, what multiplies to negative 4 that adds up to negative 3? So that's going to end up with x minus 4 times x plus 1. Again, negative 4 times the positive 1 gives me negative 4. And negative 4 plus the 1 is the negative 3. And what you want to do then is take this x plus 2 from the beginning and bring it down here. And you just strap a little f of x to it. So again, all that we did is do the synthetic division that I did on the first problems, and then we just took the answer a step further and just factored it. Now again, if you were to multiply this entire thing out, you would end up with this. So we're still factoring. It's just using a given factor already. Alright, so let's do a few more of these examples. I'll do another cubic. So something raised to the third. Start off with the opposite, which is my positive 3. Bring down the 1. I have a negative 7, a negative 20, and positive 96. So the 1 is going to come straight down. 3 times the 1 gives me 3. Negative 7 plus 3 is negative 4. 3 times negative 4 is negative 12. I have negative 20 plus negative 12, which is negative 32. And then 3 times negative 32 is negative 96, which again, when you add these together, the fact that it is a 0 means that the x minus 3 is a factor. So that's what you want with these problems at the end. So I want to just rewrite this now as, and then we're going to drop the power, so it's going to be a quadratic. So x squared minus 4x minus 32, and I want to see if I can factor that. So you're looking for what's going to multiply to negative 32 that adds up to negative 4, and that's going to end up giving me f of x equals the numbers that are going to multiply to negative 32 are going to be x and negative 8, and then x plus 4. So negative 8 times the 4 is negative 32. Negative 8 plus 4 gives me negative 4. And then just remember to bring down the original binomial from the beginning, which is the x minus 3. So that is your final factored form answer, which again, if you were just to distribute this whole thing out, you would end up with this part right here. So now we're going to go on to something that is raised to the 4th power. So I'm going to start off, it's going to work exactly the same way. I'm going to start off with this opposite, so positive 1. Bring down the coefficients, so 1x to the 4th, 5x to the 3rd, negative 31x squared, negative 125, and positive 150. So just like before, first thing you're going to want to do is bring the 1 down and start multiplying. So 1 times 1 is 1. 5 plus the 1 gives me 6. 1 times 6 is 6. I have the negative 31 plus the 6, so that's negative 25. And then 1 times negative 25 is negative 25. Add these two together, and you're going to end up with negative 150. And then I'm going to take 1 times negative 150, which is negative 150. So just make sure, as you're going through these things, really be careful as you're adding these going straight down that you're watching your signs. Kind of the assurance with these problems, since I'm telling you that x minus 1 is a factor, that means your remainder would be 0. So if your remainder didn't come out to 0, that means something went wrong. So I'm going to take my remaining polynomial here, and since I had x to the 4th divided by an x, the power drops down 1, so I am left with x to the 3rd plus 6x squared minus 25x minus 150. So from here, we are looking for this to be factorable. And it is. Since I have the 4 terms, I'm going to check to see if this is factoring by grouping, and it is. What I'm going to do is factor out an x squared out of these first 2 terms. So if I divide each of these terms by x squared, so x to the 3rd divided by x squared is x, positive 6x squared divided by x squared is just the plus 6. From these 2 terms, I'm going to want to factor out the negative, and then it will be a 25. And if I divide both of these terms by negative 25, I'm going to end up with x plus 6. So since the x plus 6 is in common with them, I'm going to write that down here. I also have my original factor of x minus 1, and I don't want to forget about that. And then I take my remaining material. So I have the x squared and the minus 25. And what you want to do is see if I can go any further with this. In this case, I can. In this case, I know that x squared minus 25 is a perfect square binomial. So what I end up with is x plus 6, x minus 1, and then the rule is that these are both perfect squares. I can simplify as x plus 5 times x minus 5. So that problem just had a little bit more to it since it was raised to the 4th power. So it added a little bit more factoring towards the end of it. But again, same reasoning. If I were to take this blue function and multiply this whole thing out, you would end up with this function all the way at the top. Alright, next. And then the last problem. So same or similar as the last one. Start off with your opposite, so negative 2. Bring down your coefficients. So I have 2x to the 4th minus 3x to the 3rd minus 16x squared. I have a positive 3 and then the plus 14. So first thing is to bring the 2 down. Negative 2 times the 2 is negative 4. Add going straight down, I get negative 7. When I multiply these two out, it's a positive 14. Add going straight down, negative 2. Multiply again, so that's a positive 4. And then that's going to be a positive 7. Lastly, it's a negative 14. So a lot of the signs going back and forth here. Either way, we end up with that remainder again of 0. So I'm going to want to take these 4 values and turn them into a function. So take your highest power here, and again, it's taking a 4th divided by something to the 1st. So that tells me I'm going to have 2x to the 3rd minus 7x squared minus 2x plus 7. And what we're going to want to do with this is see what I can factor out. So out of the first 2 and out of the second 2. So I'm going to factor this by grouping. And again, I'm going to be able to take an x squared out. If I take x squared out of both of these terms and divide them, I'm going to end up with, in this first one, 2x and then minus 7. And then here, I can't take like a whole number out of both of these, like a 2 I can't divide out of both. So all that I'm going to be able to do is take out the negative 1. So divide both of those terms by negative 1. So negative 2x divided by negative 1 is positive 2x. And then positive 7 divided by negative 1 is negative 7. And that's how we end up getting this factor in common with both of them. So my common factor is negative 2x plus 7. I don't want to forget about this one all the way at the top, which is the x plus 2. And then my remaining material, which is the x squared, and this minus 1 here. So you want to see again if I can go further with this. And again, it's another perfect square binomial. So x squared minus 1 is going to factor apart. Because the square root of x squared is x, the the square root of 1 is 1, so that's my difference of squares, so x plus 1 and x minus 1. Very similar to the problem before. And it's not always going to work out that it's a difference of squares. That very ending could have said x squared plus 1, and then it wouldn't be factorable. So that's not always going to be the case, so you just want to watch and see if it is sometimes. And even before, we're not always going to end up with 4 terms here. As you saw in the first 2 examples, with these ones, sometimes you're going to even have to use like the snowflake algorithm of factoring, because that first term might come out with a number that is greater than 1. So different types of factoring. That's why we have a lot of prior knowledge and practice on factoring, and that's going to help you end up eventually solving these.